Welcome to the deep dive. We're kicking things off today, looking at a really ambitious project in the blockchain space, MegaETH.
Yeah, ambitious is right.
They're talking about speeds that sound, well, almost impossible. 100,000 transactions per second, 10 gigas of gas. I mean, wow.
It's definitely headline-grabbing stuff.
Absolutely. But, while that raw speed is fascinating, what's maybe even more interesting is how they're actually planning to get there. It seems to boil down to tackling this really fundamental challenge called data availability.
Exactly. Yeah, we often focus just on the processing speed, right? How fast can it crunch transactions?
Right.
But for a blockchain to be truly decentralized, truly trustworthy, especially at that kind of scale, well, you need to ensure the data behind those transactions is public.
Public, so anyone can check it.
Anyone can verify it. That's the real puzzle here.
Yeah.
And MegaETH's approach, it uses something called EigenDA, and it offers a really compelling solution to what's become a major bottleneck.
Okay, data availability. Let's unpack that a bit. For listeners maybe not deep in the weeds of blockchain jargon, what are we actually talking about? Why does it matter so much?
Okay, think of it like, remember in math class when the teacher said, show your work?
Yeah. Always. Didn't want just the answer.
Exactly. Data availability, or DA, is basically the blockchain showing its work. It means all the raw data, every transaction is made publicly available.
So everyone can see exactly what happened.
Precisely. That transparency lets anyone, independently check that the blockchain state think like everyone's account balance has been updated correctly following the rules.
Okay. So that's the foundation of the whole trustless idea.
It really is.
Yeah.
Without good DA, a blockchain could start to look more like, a centralized database.
Where someone behind the scenes could potentially mess with the record.
Potentially, yeah, without easy public oversight. Now, it's really important to understand why MegaETH specifically needs such a robust DA solution. They made a big architectural choice.
Yeah.
They decided to outsource their consensus mechanism.
The part that agrees on the transaction order.
That's the one. They're outsourcing that to Ethereum.
Oh, interesting. So instead of building their own super secure consensus layer, they're sort of piggybacking on Ethereum's.
Leveraging Ethereum's battle-tested system, yeah.
Yeah.
Capitalizing on its security and decentralization for that critical piece.
Smart. Let Ethereum handle the hard security part.
Right. And that lets MegaETH focus everything on optimizing its own execution, for pure speed.
Gotcha. So how does this setup work with Ethereum and this EigenDA thing?
Okay, so MegaETH is constantly talking to both. It reports snapshots of asset ownership back to Ethereum. That's the security anchor.
Right.
But then all the detailed transaction data, all the work, gets recorded onto EigenDA.
I see. So Ethereum for the final security check-in, EigenDA for publishing all the nitty-gritty detail.
You got it. Ethereum's the security backbone. EigenDA handles the data availability.
Okay. Now, you mentioned Ethereum itself has a data availability problem. How does that affect MegaETH if they're relying on the Ethereum ecosystem?
Yeah, that's a really crucial point. Ethereum has been working on its own DA capabilities. Big time.
The Dinkin upgrade, right, with the blobs?
Exactly. The Dinkin hard fork in 2024 brought in blobs. It's a much more efficient way for rollups, these chains that bundle transactions and post them to Ethereum to submit their data.
More efficient how?
Well, blobs are cheaper than the old way, using call data. Plus, they don't clog up Ethereum's main chain forever. They get pruned after 18 days or so.
Okay. Cheaper and temporary. Sounds good.
And they have their own separate fee market, which can also help with costs.
So, seems like a solid improvement. Where's the bottleneck then, especially for a super fast chain like MegaETH?
The bottleneck is the sheer amount of data Ethereum currently lets you post via blobs per block.
There's a limit.
There is. It's controlled by these things called blob targets and blob limits. The target is like the ideal capacity. If demand goes over that, blob prices go up.
Makes sense. Supply and demand.
Right. And currently, after the upcoming Pectra upgrade, the target is set at 6 blobs per block, max of 9.
6 blobs per block. How much data is that, roughly?
With Ethereum's block time, around 12 seconds, it works out to roughly 64 kilobytes per second of data availability throughput.
64 kilobytes per second. That sounds tiny in today's world.
It is. Especially when you think about what these high-performance rollups need. That's 64 KBs. That's estimated to support only around 100 megas per second and maybe 400 transactions per second.
Total, across all the rollups using Ethereum.
Across all of them combined. It's a shared, very limited resource.
Wow. Okay, so you can see the squeeze coming.
We're already seeing it. Take base, for example, it's a popular rollup. It can easily eat up 25, even 30% of all the available blob space. And that's just doing around 120 transactions per second, maybe 35 megas.
So one rollup is already taking a big chunk. Okay, remind us again, MegaETH's goals.
MegaETH is aiming way higher, over 10 gigas per second.
Giga, not mega.
Giga. And 100,000 transactions per second.
Okay.
Their own tests suggest they need a DA layer that can handle something like 20 megabytes per second to keep up that pace.
Right, so we went from Ethereum offering 64 kilobytes per second to MegaETH needing 20 megabytes per second. That's a huge gap, like orders of magnitude.
Orders of magnitude, exactly.
Oh.
Now, Ethereum does have future plans. There's PeerDAS, maybe coming in 2026.
Another upgrade?
Yeah, part of the Fusaka upgrade. It might boost the blob target to maybe 48 blobs per block.
Okay, 48 blobs. That's better than 6.
It is better, but even with that, estimates suggest it's still about 40 times too low for MegaETH's 100K TPS target.
40 times too low, even with the upgrade.
Yep. And that's assuming no other rollups are using Ethereum DA, which is, unrealistic.
Right, of course. So the bottom line is?
The bottom line, we're relying only on Ethereum's blobs for data availability. It's just not feasible for what MegaETH wants to do. Not even close.
Okay. So this brings us squarely back to EigenDA. This is the unlock you talked about. How does EigenDA actually solve this problem for MegaETH? How does it enable those crazy speeds?
Right. EigenDA is built specifically for high throughput DA. And its performance even now shows it. It's live, already doing 15 megabytes per second.
15 megabytes. Okay, that's already much closer to MegaETH's need.
Much closer. And they're aiming for 50 megabytes per second that's already running on their V2 testnet.
50 megabytes compared to Ethereum's 64 gigabits. Let's put that in perspective.
It's roughly 800 times Ethereum's current DA throughput.
800 times.
Yeah. To give you another idea, 50 megabits could theoretically handle over 250,000 standard ERC20 token transfers every single second.
Wow. Okay, that kind of capacity definitely covers MegaETH's 20 megabytes need, with room to spare.
Easily covers current needs and allows for future growth. This whole shift, thinking beyond the limits of one chain's block space for DA, that's the key insight. It's not just faster. It opens up possibilities like applications that were just too data heavy for blockchain before.
Yeah, 800 times isn't just tweaking things. That's a completely different ballgame, as you say. So what's the magic? What's EigenDA's secret sauce for this massive performance leap?
It really comes down to two key architectural differences from Ethereum.
Okay.
First is horizontal scaling. Meaning, unlike Ethereum where blob capacity is kind of fixed per block, EigenDA's capacity grows as more operators join its network.
So more participants equals more throughput.
Exactly. More operators help process and store the data. The second big piece is something called erasure-coded data sharding.
Okay, erasure-coded data sharding. Sounds complex. Break that down.
Okay, let's try it. Imagine you take all the transaction data, right, and you break it into lots of small pieces, or shards.
Okay, like chopping it up.
Yeah. Now, normally, if you just shard data and lose a few pieces, you might lose the whole picture.
Right, the data is incomplete.
But erasure coding adds redundancy. It's like creating smart backup information for the shards. So even if some shards go missing, maybe some operators are offline, you can still reconstruct the original data perfectly from the remaining ones.
Oh, cool. So it's fault tolerant.
Highly fault tolerant. These shards then get spread out across all the EigenDA operators, and each shard gets something called a KZG commitment.
KZG commitment.
Think of it like a tiny, super secure fingerprint for that piece of data. It's a mathematical proof that the data is authentic, that it hasn't been tampered with, and it lets the network check the data's integrity really efficiently without needing the whole original chunk.
Okay, so fingerprinting the pieces for security and easy checking.
Exactly. So you combine distributing the data load with this redundancy and efficient verification, and that's how you maximize both speed and reliability.
More scalable, more robust DA. Makes sense. So how does MegaETH actually use this? What's the step-by-step?
Okay, it's a pretty slick process. First, MegaETH's sequencer, the part ordering transactions, bundles up a batch of transactions.
Got it.
It sends that batch over to EigenDA.
Okay.
EigenDA then does its magic. Applies erasure coding, generates that KZG commitment for the whole batch, chops it into chunks, and sends those chunks out to its operators.
Spreading the load.
Spreading the load. The operators check the KZG commitments using something called multi-reveal proofs, store their chunk, and then send back a cryptographic signature, a BLS signature, saying, yep, got my piece, it looks good.
Okay, confirming receipt and validity.
Right. These signatures are collected by an EigenDA component, the disperser, and bundled into something called a DA certificate.
A certificate proving the data is available on EigenDA.
Exactly, a proof of availability. This DA certificate then gets sent to a smart contract on Ethereum. It's called the EigenDA verifier contract.
Ah, back to Ethereum for verification.
Back to Ethereum. That contract checks the certificate. If it's valid, the MegaETH sequencer then sends that verified certificate to another contract on Ethereum, the MegaETH inbox contract.
Okay, so basically, MegaETH outsources the heavy lifting of data storage to EigenDA, gets a receipt, and files that receipt securely on Ethereum.
That's a great way to put it. You get the speed and scale from EigenDA, but the ultimate proof and security anchor comes from Ethereum.
Very clever. It leverages the strengths of both.
Precisely. And at the same time this is happening, MegaETH also posts its state root directly to its own bridge contract on Ethereum.
State root, remind me what that is.
It's like a cryptographic summary, a single fingerprint representing the entire state of all account balances on MegaETH at that moment.
Okay, the overall ledger snapshot.
Exactly. Anchoring that on Ethereum gives it Ethereum's security. Now, here's where it ties together. If someone thinks MegaETH cheated, if they think that state root posted on Ethereum is wrong,
they can challenge it.
Yes, they can become a fraud-proof challenger. They use the DA certificate to go fetch the actual transaction data from EigenDA.
Ah, they retrieve the work that was shown.
Exactly. They grab the data from EigenDA and can then rerun the MegaETH transactions themselves to see if they get the same state root that was posted on Ethereum. It allows for independent verification.
Got it. So it's this dual approach people talk about.
Yeah.
Using both systems.
That's the term, yeah. Tapping into Ethereum for its rock-solid security and EigenDA for its massive data throughput.
Best of both worlds.
That's the idea. Yeah. Their stated goal is really to build the fastest blockchain possible, where the only limits left are basically hardware and, internet speed.
So just to bring this together then, relying only on Ethereum for posting all transaction data, it works okay for chains with, let's say, moderate speed needs.
Sufficient, yeah. But not for the next generation.
But for the kind of performance MegaETH is shooting for, you need a totally different data availability strategy.
A fundamentally different approach, yes. And crucially, MegaETH's need for more and more DA capacity seems to line up really well with EigenDA's own roadmap for getting faster and faster.
So DA hopefully won't become the bottleneck again down the line.
That's the plan. Keep DA ahead of the execution capacity.
And the end result, potentially, is a blockchain that feels almost like real-time with the capacity for, well, applications we probably haven't even thought of yet.
Absolutely. It really pushes the envelope on what we thought blockchain could do.
Okay, so wrapping up this deep dive. The secret sauce for MegaETH's performance isn't just one thing, it's this really clever mix.
Yeah, it's strategic.
They're using Ethereum's top-tier security for the crucial consensus part, but then outsourcing data availability to EigenDA, which just operates on a completely different scale than putting data directly on Ethereum.
Right. EigenDA's architecture, the horizontal scaling, the erasure coding, seems like a genuine breakthrough for tackling that DA limitation.
A paradigm shift, maybe?
Could be.
Yeah.
A really novel way to approach scaling.
And thinking about that, it leaves you wondering, right? If you solve a fundamental bottleneck like data availability this significantly, what new kinds of decentralized apps actually become practical?
Yeah.
What does that unlock for the future of the internet, for how we interact digitally? It's definitely something to think about.
For sure. Opens up a lot of possibilities.
Well, thanks for diving into that with us today. Really fascinating stuff.
My pleasure. Great discussion.